Okay, so the problem that we're going to solve is find the slope of the tangent line to the circle r equals 4 cosine theta at the point where theta equals pi over 4. Okay, so the equation for the slope of a polar graph is dy over dx equals r cosine theta plus sine theta times dr d theta over negative r sine theta plus cosine theta times dr d theta. The first thing you want to do is find dr d theta. And how you do that is you use the given r, which is 4 cosine theta, and you take the derivative of that. The derivative of 4 cosine theta would be negative 4 sine theta. So now you're going to plug in this value, like negative 4 sine theta, wherever there's a dr d theta. You're going to plug in 4 cosine theta wherever there's an r in the equation. Then you're going to plug in pi over 4 wherever there's a theta in the equation. Okay, so the first thing we're going to do, the r would be 4 cosine theta times cosine theta plus sine theta times dr d theta, which is negative 4 sine theta, all over negative r, which is 4 cosine theta times sine theta plus cosine theta times dr d theta, which would be negative 4 sine theta. Then you're going to substitute pi over 4 for theta. So you do 4 cosine of pi over 4 times cosine of pi over 4 plus the sine of pi over 4 times negative 4 sine of pi over 4 over negative 4 times cosine of pi over 4 times sine of pi over 4 plus cosine of pi over 4 times negative 4 sine of pi over 4. So now you're going to use the values that you memorized from the unit circle to substitute the cosine and sine of pi over 4 for the values. So you'd get 4 times the cosine of pi over 4, which would be root 2 over 2, times the cosine again of pi over 4, which would be root 2 over 2, plus the sine of pi over 4, which would be root 2 over 2, times negative 4 times the sine of pi over 4, which would be root 2 over 2, over negative 4 times the cosine of pi over 4, which is root 2 over 2, times the sine of pi over 4, which is root 2 over 2, plus the cosine of pi over 4, which is root 2 over 2, times negative 4, times the sine of pi over 4, which is root 2 over 2. And once you simplify all of that, it would be 2 minus 2 over negative 2 minus 2, which equals 0. So that means that the slope of the tangent line to the circle r equals 4 cosine theta would be 0. Okay, so the second problem we're going to do is find the total arc length of the cardioid r equals 1 plus cosine theta. So the arc length for a polar is L equals the integral from a to b of the square root of r squared plus dr d theta squared d theta. And the first thing you have to do is find dr d theta. And just how we did it in the problem before, you're going to use the original r equals 1 plus cosine theta. You're going to take the derivative of that, which would be negative sine theta. And after you've found the derivative, you're going to plug in that for dr d theta, and then plug in 1 plus cosine theta for r into this equation. Then the next thing you have to do is determine the interval. And that can be used either graphing it on the calculator or doing it by hand and figuring out where the interval of the graph completes its picture and goes like all the way from origin to origin. Okay, so in this problem, after I graphed it on the calculator, I determined that the interval was from 0 to 2 pi. So then to plug this into your calculator, or you could do this integral by hand, you do the integral from 0 to 2 pi, square root of 1 plus cosine theta squared, plus negative sine theta squared d theta. And if you do this on your calculator like I did, the answer would be 12.56. So that would be the total arc length of the cardioid. And that's it.